very important question in this chapter for 8 marks. Compulsory we will get 8 marks question from this chapter. Already we have studied 8 marks question. What is that? We are proved that when a particle is in SHM, displacement is expressed in harmonic functions. Acceleration is proportional to displacement but acts in opposite direction. When a particle moves along the circumference of a circle with uniform angular velocity. From that we are proved displacement and acceleration is proportional to displacement and opposite direction. Now, simple pendulum, time period and seconds pendulum. But how we can get these questions in the examination for 8 marks? Define simple harmonic motion and simple pendulum. Derive the equation for the time period of simple pendulum. Then after, what is seconds pendulum? Write its length and time period. Okay. Now, what is a simple pendulum? A weightless bob, just like a ball, a weightless bob like this. It is weightless. A weightless bob is connected at the end of twistless. What we can say? Twist. This is called twist. This is called a twisting. A weightless bob is connected at the end of twistless and also massless rope or thread is taken from the rigid support. Is called simple pendulum. What is a simple pendulum? A weightless bob. A weightless bob. A weightless bob is connected at the end of twistless and massless rope taken from the rigid support is called simple pendulum. Now, in a simple pendulum, this technical word is important. Length of pendulum. What is the length of the pendulum? The distance from rigid support to center of gravity of the bob. This is the center of gravity. The distance from rigid support to center of gravity of bob is called length of pendulum, denoted by L. Okay, now it is in mean position, pull and released. Executes on either sides of mean position. This is the mean position, pull, released. It executes on either sides of mean position. When we can pull, this is the tension in the rope. Okay, now when we can pull and released, it is execute on either sides of mean position due to restoring force. Why the pendulum executes on either sides of the mean position? When we can pull and released. Moves in this direction, then after this direction. Moves in this direction, then after in this direction. Why? Why the pendulum executes on either sides of mean position when pull and released means due to restoring force. This restoring force is proportional to displacement. Simple pendulum executes on either sides of mean position due to restoring force which is proportional to displacement. Okay, see the figure. From figure, tensile force T is equal to mg cos theta. This is the bob. This bob weight is acts in this direction. Weight is a vector. Vector is resolved into two components. One is horizontal component, another one is vertical component. That we are studied in 4th chapter. Vectors are resolved into how many components? Two. One is horizontal component, another one is vertical component. Horizontal component is expressed by cos theta. Vertical component is expressed by sin theta. That's why here, what is horizontal component of the weight? The horizontal component of the weight is mg cos theta. It is equal to tensile force. And what is the vertical component? The vertical component is mg sin theta. It is equal to restoring force. But what I am saying, it is proportional to displacement but in opposite direction. That's why tensile force T is equal to mg cos theta. Restoring force F is equal minus mg sin theta. Why? We pulled in this direction, but mg sin theta is in this direction. That's why we can take opposite sign. Now tan theta. What is the formula from tan theta? Adjacent side by opposite side by adjacent side. What is opposite side? A to B. What is adjacent side? O to A. A to B. We take as x. X is called displacement. What is L? Length of the pendulum. O to A, length of the pendulum. Here it is displacement. Displacement expressed by x or y. But here I am taken as x. In this direction is x. Okay. If angles are very small, we know the condition. For small angles, this is the condition we are studied in 10th class mathematics. For small angles, sin theta is taken as a theta and tan theta is also taken as theta. So, my f is equal to minus mg sin theta is taken as theta. Sin theta is taken as theta, tan theta is taken as theta is equal x by L. Substitute theta is equal to x by L into here, means f is equal to minus mg x by L, equation 1. From Newton's second law we know that when f is equal to ma. But when the particle lies in simple harmonic motion, when the particle lies in the simple harmonic motion, we are proved that what is the equation for acceleration? Acceleration is proportional to displacement. Acts in opposite direction. What equation we can get it? When the particle moves along the circumference of a circle with uniform angular velocity, A is equal to minus omega square x. You must be remember, this is very important point. Let us take this as equation 1. A is equal to minus omega square x. It is from SHM condition, simple harmonic motion condition. Compare equation 1 comma 2. M minus omega square x. Cancel. X cancel. Minus cancel. Omega square is equal to G by L. Remove the square. Omega is equal to root G by L. What is the omega? 2 pi by T is equal to root G by L. Take reverse. T by 2 pi is equal to root L by G. What is the T? T is equal to 2 pi root L by G. What is the T? Time period. What is the time period of simple pendulum equation? T is equal to 2 pi root L by G. What is the equation for the time period of simple pendulum? T is equal to 2 pi root L by G. But T, time period, is proportional to length of the pendulum. When length is increases, time period is increases. When length is decreases, time period is also decreases. Next, this time period is inversely proportional to square root of, what is a G? G is called acceleration due to gravity. T proportional to root L. Time period is proportional to square root of length of pendulum. But time period is inversely proportional to square root of acceleration due to gravity. Up to here you can write, you can get only 6 marks. And next, we know that one. N is equal to 1 by T. Substitute that N is equal to root G by L. What is N? N is the frequency. Now here frequency is proportional to square root of acceleration due to gravity, and frequency is inversely proportional to square root of the length of the pendulum. These two are very important. Based on that, we have 2 marks questions. In the next class we will discuss that. Okay, is it clear? Now, next one, seconds pendulum. What is called seconds pendulum? Which pendulum? Time period. Time period means time taken for one oscillation. Which pendulum? Which pendulum? Time period, capital T is 2 seconds. That is called seconds pendulum. That is called seconds pendulum. Which pendulum time period is 2 seconds is called seconds pendulum. Seconds pendulum length is 100 centimeter or 1 meter, means capital T is equal to 2 seconds, L is equal to 100 centimeter or 1 meter. For which one? Seconds pendulum. Okay, up to here it is a very important question for 8 marks. Okay, you must be practice this till you can get without any doubt and with confidently you can write on the paper. Okay, this is very important question in this chapter.